Let's set the scene. I was happily writing code for my indie game, Project Drifter, implementing feature after feature, but after implementing the most recent feature, disaster struck. The latest feature I added, these totally sick 3D walls, ended up completely tanking its FPS, which got me thinking. I see a lot of beginners asking for the best way of doing something, or not wanting to get started because they're scared they're going to get something wrong. So I wanted to start this off by saying there is no correct way of implementing anything when it comes to programming. It's just a complete myth. Any method or approach is completely valid in my opinion as long as it gets the desired effect. Will you end up writing code and doing things in your game that result in massive frame rate drops and inefficiency? Yeah, you definitely will. But that's absolutely fine because it's all part of the process. 99% of all of these issues are normally fixable in some way, and you'll learn so you don't make the same mistakes next time. It's all part of becoming a better game dev and programmer. So in this video, I want to talk about some of the things I like to think about when or even if I'm going to optimize code. These ideas and principles are the ones I applied and thought about a lot when trying to fix my game's current issues. But in reality, the sort of thought patterns can be applied to any game if it's struggling with inefficiency problems. In a normal devlog, I would now ask you to subscribe and show you lots of footage of the progress of my game, but since I've spent this last week just optimizing the game, all you'd get to see is the game going from running at 6 frames per second to running at 600 frames per second. So instead, I wanted to treat this as sort of a rough guide and tutorial to thinking about optimization, rather than just spending like 10 or 20 minutes watching me write code that brought my frame rate up to acceptable levels again. So, my first point is, only optimize if you even have to. Some people think this is a controversial take, but honestly, optimizing things properly takes a really good amount of time and can properly slow down development. If the change in frame rate from adding a new feature is 600 to 6 FPS, then yeah, you should probably look at changing your approach. But if the new feature you've just added only changes the frame rate by a tiny amount, who cares? I'd rather continue moving faster towards finishing my actual game rather than micro-optimizing every single line of code. And speaking of trying to micro-optimize every single bit of your code, the compiler is just smarter than you are. Let me explain that. Now, as I've said before, I'm a firm believer in only optimizing if you have to. This is because any individual lines of code or operations that you perform won't actually have a significant effect on the performance of your program, especially on modern hardware. Worrying about the square root function because it's inefficient or trying to load all of your variables into the same line of code won't actually make that much of a difference because the compiler will likely just take care of that for you. I think it's important that your code is much more understandable and human readable and that it gets implemented relatively quickly so you can just move on to the next feature. However, you might be thinking, if the compiler is so smart, why do we ever even run into efficiency problems in the first place? And that's a really good question. As I've said, when it comes down to individual lines of code or commands, the compiler is really good at ironing out the wrinkles. However, it can't fundamentally change the structure of what you are telling it to do as a programmer. And it's because it can't change the structure of your code and algorithms that brings me quite nicely onto my next point. You might be asking the compiler to do something that is just completely unrealistic in the bounds of the known universe. Big O notation. It's something we use in computer science to classify an algorithm according to how its time and memory requirements change according to the input size. In other words, it's an analysis tool we can use to gauge the theoretical speed of an algorithm. And this normally involves a bunch of mathematical notations that are hard to understand and I just don't like them. However, we can simplify it all to essentially fit most of our use cases with a really simple method that I like to call counting for loops. Here's how I do that. So you want to look for nested loops inside your code. That is, loops inside of other loops. We don't bother looking at the for loops that are just by themselves because those will run in on time, or they'll run in linear time, which, unless the loop is looping over something impossibly large, should be fine in most cases. A nested loop will look like this. If it's just one loop inside of another, it's said to run in on squared polynomial time. If there are 3 loops together like this, for ease of understanding it, we still simplify it to on squared time. This is because it only ever goes 2 layers deep. The second loop finishes before the third loop even starts, so we're not running a loop within another loop in that inner bit. However, if the 3 loops are all actually inside one another, then we call it on cubed polynomial time. And again, I can't stress enough that this is a simplification of the process, but for quickly analysing your own code that no one else is going to see, this is a pretty quick way of doing it. Just don't go trying to show my method to any computer science professors. But anyway, the more nested loops you have inside of loops, the slower your code will become to run for the same equivalent input size. Generally, unless the list of things we're looping through is ridiculously large, things up to on squared, so that's just one for loop inside of another for loop, will be okay in most cases. And sometimes it's just flat out necessary and the only option. For example, if your game world is a 2D grid and you need to check every single space on that 2D grid, you're going to need an on squared loop. However, things start to get really sketchy when our nested loops are on cubed or more, as the time it takes to perform loops within loops within loops just balloons even faster and faster. Sometimes to the point that there isn't even enough time in the universe itself to perform enough calculations to finish the algorithm before time grinds to a halt in the universe. So at this point, you generally want to try and avoid using these inefficient loop structures and look for an alternative approach that will achieve the same outcome. And you'll probably be surprised that a lot of the time, there is normally a solution out there, especially for a lot of the things that game devs want to do and achieve in a game. They've probably been done by someone else in another game that you've taken inspiration from. Just try and work out how they did it and then do it that way. So remember when I said that you might just be asking your compiler to do something that's completely unrealistic? You might just literally be asking your game to perform way too many calculations in one go. I personally find that I often end up writing the obvious for loop solution for a problem that is the first thing that I can imagine in my head when I come up against it. And after writing that and realizing that it's really slow, I normally need to reapproach the problem in a different way and think about how I can perhaps simplify out one of the for loops by using a different method, or ordering some data so I can use a more efficient sorting method on it. Lots of different ways of doing it, but they all take extra thinking to get them done. There can be lots of other ways we ask way too much from our CPUs though. For example, a lot of games, especially AAA games, have to contend with loading a ton of assets in and out of memory really quickly and all the time. This is a whole other topic, but it's still something to consider. But today we're just focusing on algorithmic complexity and code efficiency, as that's a problem that I've had to face recently. So in computing, and definitely in games, there is this idea of hot and cold code. Hot code is code that gets run many times per frame. An example of this might be your enemy movement code, as you have hundreds of enemies that all need to recalculate their position, their physics, their animations. Every single one of them has to do it every single frame, so that's a lot of times that same code is run. Cold code is code that will run at most once per frame, sometimes even less. In a single player game, the player code will likely be considered cold, as it will all only be run once per frame if there's one player. Now, there are several interesting ideas that spring out of this concept, and none of them were immediately obvious to me. Neither hot or cold code is inherently good or bad. The paradigm or idea just helps us think about how we should view our code efficiency and perhaps where our efforts are best spent on making code efficient. As I mentioned, the player code for a single player game will usually be relatively cold, assuming there is just one player entity. As a result, this usually means it can be more complex. You're running it infrequently relative to other parts of the code, and it's something that will normally affect things that the player will be interacting with a lot of the time. And so there generally needs to be a lot more attention to detail with something like that. You'll generally want your hot code to be easier to execute, which ideally will mean that it's a lot simpler. It's being run many times by many different things in the code, and so you don't want it to be too taxing to do. A good example of this would be in any open world RPG game. Take your player character that has huge skill trees, huge equipment lists, loads of actions they can perform, a questing system, player input, and so on and so on. This is a huge amount of stuff that just revolves around the player, but generally it only needs to be done once per frame. Now, compare that to the AIs in these open world RPG games that can often seem really dumb. They get lost, they don't have many special abilities compared to the player, they have terrible or really predictable combat skills. That's because emulating thousands and thousands of NPCs in an RPG to the same level as the player would just be impossible. It's too much complex code that would have to be run way too often. As a result, the decision making for an AI often has to be a lot simpler. However, there are ways around this. Clever design decisions can help with the illusion of intelligence or lead to emergent properties, but that's a whole other topic again. We're just talking about code today and we're not getting sidetracked. Another thing you could do to make hot code more efficient is to just try and make it colder. If we use our thousands of NPCs AI as an example, do each of those AI entities need to recalculate their path to the player every single frame? Or can that be done every other frame? Or every 8 frames? Every 10 frames? Perhaps they only need to recalculate their path once per second? Obviously, this type of code cooling is incredibly case specific and it might not work in certain scenarios, but if you spot an area where you can apply it, it can be very effective. Like in the example of the game I'm currently working on, Project Drifter, the first way I wrote the code for those 3D dynamic walls recalculated the bottom corner positions every single frame. But in my game, the bottom of the walls never even move. It's only the top of the walls that recalculate relative to the camera's position. I don't even need to calculate the bottom coordinates once every 1 million frames. I just need to make sure I've calculated them correctly when the object is created, and then I can just leave that code until forever. It's stuff like this where you write technically working code that can be easily overlooked. It's just wasted CPU cycles that can be better spent elsewhere. And we have hit the rhyming segment of the video where I come up with catchy slogans in a feeble attempt to try and help myself and other people remember the principles I'm about to talk about. So, the first one. Occlusion culling is way too smart of a word. I prefer the terms can't see me, disappeary. In Unity, to achieve can't see me disappeary, all you have to do is click on a bunch of tags and checkboxes and it seems to do it for you, which is pretty nice. But in GameMaker, I found that I had to write a lot of it manually myself. So I initially thought I could just cold code my 3D wall, draw and logic functions if they weren't on screen. That's less code to run each frame, right? But what I didn't factor in was that the game still has to step into those functions just to be told,
oh wait, no, don't do that.
And then step back out of them again. This sort of going into a function for absolutely no reason and then immediately coming out of it again is actually kind of really inefficient if you do it a lot. What is in fact way more efficient is to just disable the object entirely if it's out of your view range. This way, the game doesn't even consider looking into the function just to be told to come back out of it again. It just skips over the function entirely. Then if the object ever becomes close enough to the camera to be useful again, we just reactivate it and then those functions start running again. The main point of can't see me disappearing is that we don't want to spend time logicking and drawing things that the player isn't even going to see or interact with in any way while it's not in use. And we don't even want to waste time establishing that fact. Now, a sibling principle for can't see me disappearing is code with no use is CPU abuse. Do you have code in your code base that just lies around and executes but doesn't actually serve any purpose in your game? It's really easy to let it happen, especially after months of working on a game project, and it just gets a bit messy. So maybe spend one afternoon to just clean it up because it's eating CPU cycles. Are there instances or objects in your game that just hang around for way too long after they've served their purpose in your game? Just delete them. I think the biggest one of all in today's sort of way we're taught how to do programming is that we object orient things way too much. Like, does everything have to be its own unique object or class with all its own properties and setup features and initializations? Or does it have a function that can actually be performed by an already existing object that just runs some additional calculations? This last object orienting too much thing really got me with when I was optimizing Project Drifter. I had separated the sort of wall object that players see into what was actually two separate objects in the code. You had the object that would handle the drawing of the 3D wall, but then you also had the object that would handle the physics aspect of the wall. When in reality, I could just combine those two objects into one object that just performed both the drawing calculations and the physics calculations, and there was no difference, to the player at least. Where there was a difference though, was in what was happening underneath the hood in the code. Because there were two objects that served slightly different purposes, but really could be the same one, they shared a lot of duplicate information that ate up loads of space in RAM. So after combining these two objects into one, I basically halved the number of wall objects that needed to be created, and so halved most of the variables that those wall objects used. It also halved the amount of logic and draw functions that we step in and out of, and so actually contributed a pretty decent chunk to the efficiency of the wall objects. I think sometimes we have a tendency to over-engineer a simple problem that could be solved with a simple solution because we're trying to over-plan ahead for the future. But it's understandable why we do that sometimes, because we're not sure if we're over-planning or if our engineered solution is actually justified when we need to change it later on. I think that just taking a second sometimes to question your code architecture design decisions is something that we should all do more often. And it's using a combination of all of those design ideas and thought patterns and rethinking that helped me actually get my game to go from running at 6 FPS to 600 FPS. I knew I was going to have to optimize those 3D walls as I kind of intend them to be a core part of the aesthetic of the game. And I knew it should be possible because I've seen other games do 3D walls before. It's not exactly a groundbreaking idea. But it did take me a solid week of optimization and learning and research to work it out properly. But now they're implemented super cleanly and we can continue to move on to the next features to add to the game. I don't think any subsequent features that I want to add to the game are going to be as intensive as working out how to draw this huge map that I want to have randomly generated in the game. But I'm sure that if any of the systems I end up making do become as complex as drawing these huge maps, we can use the same tools and apply the same thought processes to the problems to come up with solutions. So with that, if you're still here, I want to thank you so much for watching this far into the video. And it also indicates to me that you found it useful or interesting, and so you might want to consider subscribing for more content. This video was a bit more of a different format to usual, but I do like to try and put out these information-y tutorial teaching type videos every now and then. Follow me on Twitter or even join the Discord where you can ask me questions directly, and I always like to try and help if I can. Next week, I think we'll be back with another Project Drifter devlog of actual updates to the content of the game instead of just improving the frames per second on it. So stay tuned for that, and until next time, goodbye.